Hi everyone, welcome back to another Practice Together session. This topic is on the foots of the perpendicular from a point to a line. Now if you haven't already seen the tutorial video on this topic, do check it out, which is linked in the description box below. So if you're ready, let's jump straight into practice question number 1. Now our objective is to find the position vector OF, denoted by F, which is the foot of the perpendicular from point P to the line passing through AB. Now in such questions, I would recommend you to sketch the diagram, which is shown over here on the screen. In order to find the foot of the perpendicular, we will need to have two vital ingredients. The first will be the equation of the line L. In this case, the line L is passing through AB. And the next ingredient that we need to have will be the coordinates of point P, which is 5, 1, 1. So the equation of line AB is equals to 3, 1, 2 plus lambda 4 minus 3, 2 minus 1, 3 minus 2. Now this expression over here refers to the vector AB, which is OB minus OA, for some values of lambda. This will be equals to 3, 1, 2 plus lambda 1, 1, 1. Next, let F be the foot of the perpendicular from the point P to AB. Now OF actually lies on the line AB, so the generic position vector of OF is equals to 3, 1, 2 plus lambda 1, 1, 1 for some values of lambda. Simplifying, we will have 3 plus lambda, 1 plus lambda, and 2 plus lambda. So in the next step, let's make use of the property of the perpendicular vectors. Alright, so because F is the foot of the perpendicular, therefore PF or vector PF dot the direction vector of the line AB is equals to 0. Now PF is equals to OF minus OP, therefore we will have 3 plus lambda, 1 plus lambda, and 2 plus lambda minus the coordinates of P, which is 5, 1, 1, dot the direction vector of the line passing through AB, which is 1, 1, 1, is equals to 0. Let's try to simplify this further. We will have minus 2 plus lambda, lambda, and 1 plus lambda, dot 1, 1, 1 is equals to 0. We will then have minus 2 plus lambda, plus 1 plus lambda equals to 0. So solving this equation, the value of lambda is equals to 1 over 3. This value is very important because we can then use to substitute this value of lambda into OF. So the position vector of OF is equals to 3 plus 1/3, 1 plus 1/3, and 2 plus 1/3. Simplifying further, we will then have 10 over 3, 4 over 3, and 7 over 3. Now if you want to go one step further, we can factorize 1/3 out from this column vector, and this will give us 1/3, 10, 4, 7. So always check if you have answered to the question. In this case, we have answered to the question because all we need to find is the position vector of OF. Now let's move on to practice question number 2. We are given quite a bit of information over here, but not to worry, the more information you have, the more we can use it as hints to help us answer to the question. Now we are going to find the position vector of the point C in terms of A and B. You realize that point C lies on AB such that AC is equals to 2 of CB. Very quickly, let's do a rough sketch of the diagram that illustrates this scenario. So C lies between A and B with a ratio of 2 to 1. And this sort of associates to the ratio theorem that we have learned. So using the ratio theorem, we can then find vector OC. Now, vector OC is equals to A plus 2B over 3. And this will be equals to 1/3 A plus 2B. If you have difficulties remembering the ratio theorem, not to worry. Always remember the alternate pairs with each other. So this means that 1 pairs with A, 2 pairs with B, and you divided it by the total value in the ratio, which is 2 plus 1 equals to 3. Thus, we will then have 1/3 A plus 2B. Next, we are going to show the length of projection of vector OC on vector OB is 3/2. If you need more clarifications on the length of projections, do check out the video that is linked in the description box below. So the length of projection of OC on OB is equals to, include a modulus, vector OC dot unit vector of B, which is denoted by B over the modulus of B. By substituting OC into this expression, we will then have 1/3 A plus 2B dot B over 2, and it is at this point that we can extract or factorize the constants that are inside the modulus. 1/3 multiplied by 1/2 is 1/6. Let's bring that out, and it will be multiplied with A plus 2B dot B. You see, it is much simpler to manage this expression rather than dealing with all the constant terms that is inside the modulus. So simplifying, we will then have 1/6 A dot B plus 2 modulus of B squared, because B dot B is equals to modulus of B squared. Now the question says that A dot B is 1 and the modulus of B is 2. Therefore, we can substitute all these values into this expression to give us 1/6 modulus of 1 plus 8. By simplifying further, the length of projection of OC onto OB is equals to 3/2. And don't forget to write the word shown so that we can answer to the question. Now there's a little part that we need to find over here, which is to deduce the position vector of n. When you see the word deduce, it is usually using the information that was found previously, and the steps aren't that long. So if you can see from the diagram, n lies on the vector OB. We can then make use of the unit vector of B, which states that it is in the direction of B with a magnitude of 1. And n lies on B. Thus, using this property, the vector ON is equals to 3/2 multiplied by the unit vector of B. So this will be equals to 3/2 B over the modulus of B, which is equals to 3/2 B over 2, since the modulus of B given in the question is 2. And by simplifying further, position vector of ON is equals to 3/4 B. Now in the last part, we are going to find the value of lambda such that C, D, and N are collinear, where OD is equals to A plus lambda B. If you're lost on what to do, not to worry. What we can do is to sketch the position of D on the diagram. So if C, D, N are collinear, it means that point D lies on CN. And this also means that DN is perpendicular to OB. Now when you hear the word perpendicular, always associate it with the property vector A dot vector B is equals to 0. So we can also conclude that vector DN dot vector OB is equals to 0. Now since we have the position vector of OD, we can then find what is dn by using 3/4 b minus a plus lambda b dot b is equals to 0. Let's try to simplify this expression by multiplying b into the brackets. So we will have 3/4 modulus of b squared minus a dot b plus lambda modulus of b squared equals to 0. By substituting the values that were given in the question, we will have 3/4 2 squared minus 1 plus lambda 2 squared equals to 0. 3 minus 1 plus 4 lambda equals to 0. And by solving for lambda, the value of lambda will be equals to half. Now I do hope you have learned something from this practice session. If you need to explore further concepts related to vectors, do check out the individual playlist that is listed in this channel so that you can build your foundation and excel in H2 math.